what if, like, you know how we're always looking for ways to make our applications more flexible and powerful, right? Well, what if we could actually, like, empower them to compile code on the fly while they're running? I mean, think about the doors that would open in terms of customization and extensibility, just incredible possibilities, you know?
Yeah, absolutely. You've hit on a really fascinating concept there, and that's exactly what we're diving into today with this Delphi library called libFPC.
libFPC,
So
yeah.
imagine this. You've got your Delphi application, and using this libFPC, you can actually embed the FreePascal compiler, FPC, right inside.
So it's like bringing the whole compiler, like the thing that turns code into programs, right into the application itself.
Precisely.
Wow. Okay, so just to clarify, libFPC, as I'm understanding from the material we have here, is a Delphi library that gives your applications the ability to use the free Pascal compiler. And what that means is you can compile Pascal source code, so the actual code itself, and turn it into executable files, DLLs, even some kind of custom binary formats, all while the application is running.
That's exactly right.
So it's like having a mini development environment living inside your program.
Yeah. It's, I mean, you can probably already start to see how many possibilities this opens up.
Yeah, definitely. The sources actually mention a lot of potential uses.
Oh, absolutely. We're talking about being able to create plug-in architectures. Imagine your users could write Pascal code, and your application could just, like, compile and run it on the fly.
Yeah, okay.
And then you've got scripting engines, give your users a nice, safe language like Pascal to automate stuff within your app.
Oh, right, right. I see where you're going with this. And then there's this concept of code playground.
Oh, yeah, code playgrounds. Think
Yeah.
about online environments, right?
Yeah.
Where people can just type in Pascal code, see the results immediately, all powered by your application.
Oh, that's cool. That's really cool. And for us developers, like, it even hints at runtime compiler toolchains, which I have to admit, that's a pretty wild concept.
Yeah, it's definitely pushing the boundaries of what we traditionally think of as application development.
So where do we even begin with something like this? I mean, how does libFPC actually work, and what are the key things it can do?
All right, well, let's start by breaking down the core features and functionality.
Okay, features and functionality. Let's do it.
So the fundamental idea, and this is like the heart of it all, is runtime compilation of Object Pascal source code using FPC.
Okay, runtime compilation. So not just running pre-compiled code, but actually taking the Pascal code and turning it into a working program while the application is already running.
Yeah, that's the key distinction here. And it's not about calling some external compiler. It all happens within your application.
Oh, okay, I see. So it's all self-contained.
Exactly. And then on top of that, you've got the different types of output it can produce. We're talking EXEs, standard programs, DLLs, those reusable code libraries, and even custom binaries, which is, really interesting.
Custom binaries, yeah, that sounds intriguing. So it's not just limited to those common formats.
Nope, you've got flexibility there. And another important thing to understand is that this is true native compilation.
Okay, native compilation. So what's the real world impact of that? Does it affect the performance of the code that's compiled this way?
It absolutely does. Native compilation means that the Pascal code gets translated directly into the machine language that your computer's processor understands.
Okay, so no middleman, no interpretation, just straight to the hardware.
Right. And that usually means faster execution, more efficiency compared to, interpreted languages or those that use intermediate code.
Makes sense. So more speed, more efficiency. That's a big plus. And the material also emphasizes full control over the build process, which I think is really important.
Oh, absolutely. It gives you fine-grained control over how your code is compiled.
So you can really tweak and optimize things to get the exact results you need.
Exactly.
Now, one of the things that really caught my eye was this concept of inline project directives. What are those, and how do they actually work?
So this is where libFPC gets really clever. Basically, it allows you to embed special comments, these directives, right inside your Pascal source code. And these directives, they tell libFPC how to compile that specific piece of code.
So it's like configuration built right into the code itself.
Yeah, exactly.
It's pretty cool. And the sources give us some good examples, right?
Oh, yeah, plenty of examples. For instance, you can define what kind of application you're building. Like, if you want a command line tool, you'd use at APType console. And for a graphical application, it's at APTypeGay.
Right, pretty straightforward. So it's like, telling it what kind of programming you're aiming for.
Exactly. And it goes beyond just the application type. You can set things like the output path, so where the compiled file ends up.
Okay, output path.
Yeah, like if you want it in the same directory as your source code, you'd use it a DPAP path.
Got it. And you can even specify the icon for the executable, right? It says axoncon main.ico.
Yeah, that's right. Notice the slight difference in syntax there with the dot before the at for icon-related
Oh,
directives.
yeah, I see that. That's important to remember. And what about managing like external dependencies? So if your Pascal code relies on other files or libraries, how do you handle that?
Well, for that, you've got the at search path directive.
Okay.
This basically tells the compiler, hey, look in these specific folders to find any units or libraries that my code needs. And you can include multiple paths separated by semicolons.
Oh, okay. So it's like setting up a search path for the compiler to follow.
Exactly. And then for different stages of development, you have at build config debug and at build config release.
Right. So you can switch between a debug build, which would have extra information for debugging, and a release build, which would be optimized for performance.
Precisely. And then there's also control over version information using directives like at version info, yes or no.
Okay, version information. So you can basically decide whether or not to embed version details into the compiled output.
That's right. And if you do choose to include it, you can even set the specific version numbers, like the major, minor, and patch versions, all right there in the code.
Oh, wow. And the sources also mention directives for the product name, description, company name, even the copyright.
Yeah, you can really embed a lot of metadata directly into the compiled output.
So it's like having complete control over the identity of your compiled code. That's pretty amazing.
It really streamlines the whole process. And then there's this really cool capability that the sources highlight,
Yeah.
the ability to output EXEs and DLLs directly into memory.
Okay, directly into memory. Now that sounds pretty advanced. What's the benefit of that as opposed to, just saving it as a file on the disk?
Well, this opens up some really interesting scenarios, especially for what's called in-memory dynamic code generation and execution. Imagine your application could generate Pascal code based on some user action or internal logic, and then compile and run that code immediately, all without ever writing it to the disk.
Oh, okay, I see. So the code exists and runs entirely in memory.
Yeah, and that can have security implications, no easily accessible file for someone to tamper with.
Right, that makes sense. And it probably has performance benefits too, right?
Oh, absolutely. It can be much faster in certain situations because you're avoiding all the overhead of disk operations.
So it's like the code just materializes and runs and then it's gone.
Yeah, it's pretty slick.
So let's say I'm sold on this libFPC thing. How do I actually get started using it in a Delphi project?
All right, so the setup is actually pretty straightforward. You first need to download the libFPC library itself, which you can get as a zip file from its GitHub repository.
Okay, GitHub, got it.
And if you're feeling adventurous, you can even fork the repository, which means you can contribute to the project.
Fork it, I like that.
Once you've got the library, you simply add the libFPC unit to the uses clause in your Delphi code.
Okay, uses clause, that's where we bring in external libraries, right?
Exactly. And that gives you access to all the libFPC functionality.
Yeah.
And then the fun begins.
The fun begins. All right, so the sources include some basic usage examples.
Oh yeah, they do a good job of walking you through the basics.
The first one shows how to compile a Pascal source file, let's say it's called test.pes, into an executable. Can you walk me through that real quick?
Sure, so the example starts by creating an instance of the libFPC class. This is basically your entry point to the library's features.
Okay, so it's like creating an object that represents the compiler within our application.
Yeah, that's a good way to think about it. And then you use the setProjectSource method to tell libFPC which Pascal source code to compile. In this case, it uses the PS file constant and provides the file name test.pes.
PS file test.pes, got it. So we're pointing it to the file that contains our code.
Exactly. And finally, you call the compile method. This is where the magic happens. It actually compiles the code.
Compile, all right, let's compile it.
And it returns a true or false value, indicating whether the compilation was successful or not.
Okay, so we can check if it worked.
Yeah. The example then just displays a success or failure message based on the result.
Pretty simple. And
Okay.
it also has a try.finally block, which I'm guessing is for cleaning up resources.
That's right. It ensures that the libFPC object is properly freed, whether the compilation succeeded or not.
Okay, good practice, good practice. So that's how we compile a file. The next example shows how to compile a Pascal source file, again into an exe, but then run it directly from memory.
Yeah, this is where it gets really interesting.
What's different in this case?
So after you've specified the source file using setProjectSource, the key difference is that you call setOutputPathCacheDir.
Set output to cache tier. Okay.
This tells libFPC, hey, don't write the compiled exe to a file, put it in memory instead.
Oh, I see. So it's all happening in RAM.
Right. And once you call compile and it's successful, you can then use the runexe method to actually execute the code that's now sitting in memory.
Runexe. Wow. And in the example, it even passes an argument to the program, the string 7.
Yeah, you can pass arguments to the program just like you would from the command line.
That's really cool. And it looks like runexe also lets you get the exit code of the program.
Yeah, it returns the exit code, which can be useful for checking if the program ran successfully or not.
So this is really demonstrating that whole FreePascal in your pocket concept, right?
Absolutely. Compiling and running code dynamically, all without any external files.
Now we're cooking. The third example then moves on to compiling a Pascal source file, but this time into a DLL in memory, and then loading and using it.
Yep, this one is a bit more involved, but it shows how to work with DLLs, which are super useful for creating reusable code modules.
Okay, DLLs, I've heard of those, but I'm not, super familiar with them.
So think of a DLL as a package of code that you can load and use from within your application, kind of like a plugin.
Okay, a plugin, got it. So how do we compile to a DLL and then load it?
So similar to the in-memory exe example, you first compile the source code into a DLL using setupPathCacheDir and compile.
Right, so we're compiling to memory again.
Exactly.
Okay.
And if that succeeds, you then use the load DLL function.
Load DLL, okay.
This function tries to load the compiled DLL into your application's process, and it returns a handle if it's successful.
A handle, what's that?
It's basically a way to refer to the loaded DLL.
Oh, okay, like an ID.
Yeah, like an ID. And if the handle is valid, meaning the DLL loaded correctly, you can then use getProAddress to find the memory address of a specific function, or procedure as they're called in Pascal, within the DLL.
GetProAddress, got it. So we're finding the entry point for the function we want to call.
Exactly. And in the example, it looks for a procedure named test.
Test. Okay.
And if it finds it, it then calls that procedure.
So we're actually executing code from the DLL that's now loaded into memory.
That's right. And finally, it's important to clean up by unloading the DLL using free library.
Free library, right, to release the resources.
Exactly. So that's how you can dynamically load and use code from a DLL that you've compiled on the fly.
That's pretty powerful stuff.
Yeah, it opens up a lot of possibilities for modularity and extensibility.
All right. And then we have the fourth example, which is even more mind-blowing. This one shows how to compile Pascal code directly from a string within your Delphi code.
Yes. This one really showcases the dynamic nature of libFPC.
I mean, compiling from a string, that's just next level.
It is, isn't it?
Yeah.
So instead of loading the source code from a file, you use the pass string constant with setProjectSource.
Okay, string. So we're telling it that the source code is coming from a string.
Precisely. And then you provide it with a Delphi constant calledCcode.
Ccode, all right.
And this constant holds a string containing the actual Pascal source code.
So the Pascal code is embedded right there in our Delphi code as a string.
That's right. And in the example, the Pascal code defines a simple DLL that exports a procedure called test01, which displays a message box.
Test01, got it. So it's a very basic DLL.
Yeah, just for demonstration purposes. And then the rest of the process is similar to the previous example. You compile this string into a DLL in memory, load it, get the address of the test01 procedure, call it to display the message box, and then unload the DLL.
So we're basically generating code, compiling it, and running it all from within our Delphi application.
Yeah, that's the power of dynamic code generation.
That's incredible. I can already see so many potential applications for this.
It really opens up a lot of creative possibilities.
Now, the sources briefly mention a fifth example that involves using libFPC as a command line utility through something called the CLI method.
Yes, the CLI method.
Yeah.
So while the main focus of libFPC is on embedding the compiler within your application, it also offers this command line interface.
Okay, command line interface. So we can interact with it from the terminal.
That's right. The example code suggests that if you were to run your Delphi application, the one that uses libFPC, from the command line, it could either display some help information about the available options, or it could perform a specific compilation task based on the commands you give it.
So it's like a dual-purpose tool.
Exactly. You get the in-application functionality and the ability to use it from the command line as well.
Okay, that's pretty versatile. So we've covered how to get started with the basic compilation and execution, both to files and directly to memory. Let's go back to those project directives.
All right, those inline commands that we talked about earlier.
Yeah, they seem like a really elegant way to control how your dynamic Pascal code gets compiled.
They really are. These directives, as their name suggests, are embedded directly within the Pascal source code itself.
Okay, so they're like instructions that are part of the code.
Exactly. They're usually placed at the beginning of a file inside those special comment blocks.
And they give you a way to control the compilation process without needing separate configuration files or anything like that.
Yeah, it keeps everything self-contained and easy to understand.
So let's recap some of the key directives that the sources highlight. We already talked about at AppType console and at AppType guy for setting the type of application.
Right, those are the basics.
What other important directives should we know about?
Well, there's @output path, which, as we discussed, lets you specify the output directory for the compiled file.
Okay, so we can control where the output goes.
And then there's @xicon, main.ico, for embedding an icon into an executable. Again, remember that slight syntax difference with the dot before the @jet?
Right, the dot syntax for icons.
And for managing external dependencies, there's the @searchPath directive.
Search pass, okay. So we can tell the compiler where to look for units and libraries.
Precisely. And you can include multiple paths there.
That's handy. And then for controlling the build configuration, we have @buildconfig_debug and @buildconfig_release.
Yeah, those are essential for switching between debug and release builds.
So we can have different builds for development and for distribution.
Exactly. And for version information, we've got @version_info no and @version_info yes, along with directives for setting the specific version numbers.
Right, so we can control whether version details are included and what those details are.
And there are also directives for setting things like the product name, description, company name, and copyright information.
So it's really comprehensive in terms of controlling the identity of the compiled output.
It is.
Oh.
And it's all done in a very clean and intuitive way.
Now, let's say someone is really intrigued by libFPC and wants to learn more or even get involved in the project. What kind of support and resources are available?
Well, the sources do a good job of outlining the community aspects of the project. They encourage users to report any issues or bugs using the GitHub issue tracker.
Okay, GitHub issue tracker, that's where we report problems.
Exactly. And for general discussions, asking questions, or sharing ideas, there's a forum on GitHub discussions and also a Discord server.
Oh, so there are multiple ways to interact with the community.
Yeah, you can choose what works best for you. And for those who might be new to Delphi, they even provide a link to Learn Delphi, which is a great resource for getting started with the language.
Oh, that's really helpful. And what about contributing to the project itself?
They definitely encourage contributions. Reporting bugs, suggesting features, even submitting pull requests if you've made code improvements.
Wow, so it's a very open and welcoming project.
Absolutely. And they even have a contributors graph on GitHub, which recognizes everyone who has contributed.
That's always nice to see. Now, what about licensing? What kind of license is libFPC distributed under?
It's distributed under the BSD3 clause license.
BSD3 clause, okay. And what does that mean in practical terms?
It's a very permissive open source license. Basically, it gives you a lot of freedom to use, modify, and redistribute the software, both in its original form and in compiled form.
So it's pretty flexible in terms of how we can use it.
Yeah, it's designed to be easy to integrate into your own projects.
And finally, if someone finds libFPC really useful and wants to support its development, what options are available?
Well, they encourage sponsorship through their GitHub sponsors page.
Okay, GitHub sponsor, so we can directly support the developers.
Exactly. And they emphasize that any contribution, big or small, helps.
That's great. And are there any other ways to support the project, even if we can't contribute financially?
Oh, absolutely. They suggest things like starring the repository on GitHub to show your appreciation and help increase its visibility.
Okay, starring the repo.
Yeah, and sharing it with others, reporting bugs, submitting fixes, suggesting new features. Basically, being an active member of the community.
So it's all about contributing in whatever way we can.
Exactly.
So to sum it all up, libFPC is a really impressive library. It brings the power of the FreePascal compiler right into your Delphi applications, and it enables you to do some really amazing things with dynamic code generation and execution. I mean, it really lives up to that FreePascal in your pocket tagline.
It does, doesn't it? And it opens up a whole new world of possibilities for how we can design and extend our applications.
Yeah, it's really mind-blowing. Just imagine being able to empower your users to write their own custom logic in Pascal, and then your application can just compile and run it seamlessly.
Yeah.
I mean, the potential for customization and extensibility is huge.
It really is. And I think we're only just scratching the surface of what's possible with dynamic code generation and execution.
That's an exciting thought. So if you're intrigued by what we've discussed today, we highly encourage you to check out the resources we've mentioned, the GitHub repository, the Discord server, and start exploring libFPC for yourself. Who
Hmm.
knows what amazing things you might create with it.
Absolutely. It's a powerful tool waiting to be unleashed.